Hi my dear students, in this video I will explain the difference between the theoretical yield and the actual yield in stoichiometric calculation. Theoretical yield is the maximum amount of product that can be produced from a given amount of reactant, while the actual yield is the actual amount of product that are measured, or we can say the measured amount obtained of the product. I will give you an example. Suppose you burn 12 grams of carbon in oxygen to produce carbon dioxide. What is the maximum yield I can get from carbon dioxide? How can I know this amount? You need to get it only from stoichiometry of the chemical equation. Because if you know that 12 grams of carbon reacts, so you can guess how much carbon dioxide should be produced. How? Again, you need to change mass A into mass B. So you'll get mole A and then mole B and then mass B. So if you have mass of A divided by the molar mass, which is 12 also, you will get 1 mole. How many moles you expect to get from B? Work out the mole ratio, which is here 1 to 1. So I'm expecting that to get only 1 mole of carbon dioxide. What is the mass of 1 mole carbon dioxide? You will multiply the number of moles into the molar mass, which is 44. You will get 44 grams. So if you burn 12 grams of carbon in excess oxygen, you expect to get 44 grams of carbon dioxide. We call this amount theoretical yield. When you make the experiment in the lab, you may get a different quantity. The quantity that you get, we call it actual yield. Suppose you get 30 grams only of carbon dioxide and not 44 grams. So 30 grams of carbon dioxide, which is measured and obtained in the lab, we call it actual yield. To know how much you were accurate while you're doing the experiment, you need to calculate what we call percent yield or percentage yield. Percentage yield equal actual yield over theoretical yield into 100. So the actual yield is 30, theoretical yield is 44, multiplied by 100, you'll get the percent yield equal 68%. This is the percent yield of the reaction. I want to focus here on the limiting reactant and excess reactant or reagent. Let's go to the previous example of burning carbon and oxygen to produce carbon dioxide. And you use 12 grams of carbon and 50 grams of oxygen, and you produce 44 grams of carbon dioxide. And you are asked what is the limiting reactant and what is the excess reactant. Limiting reactant is a reactant which exists in an amount less than what's required for the reaction to take place, while the excess reactant or excess reagent is a reagent which exists in an amount exceed what's required for the reaction to take place. Now you are given two quantities. Ignore this quantity now. 12 gram and 50 gram. In order to know which one of them is limiting and which one is excess, you need to convert both of them into moles. So draw a table. The reactant you are having, the mass is given, and then convert them to moles, divide by the molar mass. 12 over 12 equals 1. 50 over the molar mass of oxygen 16 into 232 equals 1.6 moles. So next step, you need to work out mole ratio. The mole ratio, as per the previous balanced equation, 1 mole of carbon reacts with 1 mole of oxygen. So if I have 1 mole of carbon, I need only 1 mole of oxygen, but we do have more. This means that oxygen is an excess reagent and the other one will be limiting and the one which controls the rate of the reaction. So carbon is the limiting reactant in this equation. I have an example for you. You can find it also in the revision guide. 2KClO3 dissociate giving 2KCl plus 3O2. What is the percent yield? And you are of oxygen. But what you are given? You are given 12.3 grams of KClO3. And you are given the molar mass of KClO3, 123. And you are given the mass of oxygen produced, 3.2 grams. You are given also the molar mass of oxygen, 32. Convert the mass into mole. So moles of KClO3 equal mass given 12.3 over the molar mass 123 equal 0.1 mole. You are given also the moles of oxygen given or produced, moles of oxygen. You can calculate it by dividing the mass over molar mass, 0.1 mole. So how can I know the percent of oxygen? You need to get the theoretical yield and compare it with the actual yield. Theoretically, as per the mole ratio, I have 2 moles of KClO3 react to produce 1 mole of oxygen. 3 moles of oxygen. So the mole ratio between KClO3 and oxygen is 2 to 3. If I reacted 0.1 moles of KClO3, how much you expect from oxygen? You will work out the cross multiplication, okay, which is 0.1 into 3 over 2. So it will be equal 15. You are expecting to get 0.15 moles of oxygen, but actually we got only 0.1. So the percent yield equal theoretical yield, the actual yield 0.1 over the theoretical yield into 100. The answer you will get is 66.7%, which is equivalent to B in your answer sheet. If you go to the question paper, question number 6, the answer is in page 20, the answer is B. I have another problem here for you. If we have 2NH3 reacts with 3 CuO to produce nitrogen plus 3 Cu plus 3 H2O. What you are asked? You are asked to calculate how much nitrogen gas will be formed, and it's given to you the mass of ammonia, NH3, 18 grams of ammonia are used, and you are given also the molar mass of ammonia, and from a copper oxide also you are given 82 grams of copper oxide, and the molar mass is 80. How can we solve this problem? You are given two reactants. We can't solve any problem with two reactants unless you get the limiting reactant. In order to find the limiting reactant, draw a simple table and write what's given. First, you are given information about NH3, ammonia, and CuO, copper oxide. You are given the masses, here 18, and from copper oxide 82. You are given also the molar mass, 17 gram or mole per gram. Gram per mole of ammonia, and the molar mass of copper oxide is 80 gram per mole. The next step, yeah, that's correct. You need to find the number of moles. You divide the mass over molar mass. Here also you need to divide the mass over molar mass. Here are the number of moles that we get from those calculations. Next step, you need to look for the mole ratio between NH3 and CuO. By looking up the equation, you will find that the mole ratio is 2 to 3. For every 2 moles ammonia, I need 3 moles of copper oxide. Let's take any of those values, any one of them. So if I took this, so what is the expected value of copper oxide? Yeah, what we will do? Yes, cross multiplication. I got a value of 1.6 moles. So if you are using a 1.06 moles of NH3, you need 1.6 moles from copper oxide, but I have only 1.025, which is less than the expected quantity to react perfectly. And this means that we have excess from ammonia. And the copper oxide is the limiting reactant. So I will write here copper oxide is the limiting reactant because the amount given is less than what's required for the reaction. Limiting reactant. So this is the one that we are going to depend on to solve our problems. Our problem is to find mass of nitrogen gas formed. Work out the mole ratio again. But here you will work out the mole ratio between copper oxide, which is our limiting reactant, and the nitrogen gas. The mole ratio here is 3 to 1. 3 to 1. But what we have from copper is 1.025. So how much nitrogen you expect to get? Yes, you will work out cross multiplication. So the moles of nitrogen produced will be 1 into 1.025 over 3. 0.34 moles. But he's asking how much. How much means mass in gram. So the last step is to find mass of nitrogen. From mole to mass, you multiply by the molar mass that you will get from periodic table. 14 into 2, 0.34 into 28, you will get the final answer. 9.6 grams. So if any problem you are given in exam and you are given two quantities, both of them are in the reactant side, you need to find which one of them is the limiting reactant, because this is the one that you are going to depend to solve the rest of the problem. How to find the limiting reactant? Convert mass to moles. You are given masses. Divide by the molar mass, you will get the number of moles from each of the reactant. And then work out the mole ratio. Cross multiply. Take one of the values, cross multiply. You will know that if the one which is in quantity less than what's required for reaction is the limiting reactant, and this is the one that will be used. If you find the one that you selected was an excess reactant, so use the other value as limiting reactant.